361. Number 39. They told us this. So 39, they said, it's a fifth degree. It has 1 with a 0 multiplicity of 2. So x equals 1 is going to show up 3 times. That's what that meant. Negative 2 is the only other 0. So x equals negative 2. And then the leading coefficient equals 2. So if it's a fifth degree, I need 5 of them. I have 3 here, so that represents in factored form x minus 1 cubed. And then if the only one is this one, it's going to be x plus 2 squared. And then if the leading coefficient is 2, that means if I multiply this all out, this would be x times x times x times x times x would be x to the 5th. We need to multiply the whole thing by 2. So this is what I was looking for. Why don't I want you to multiply it out? Well, because that would just take you a lot of time. And do we need it multiplied out? Only to see it as a polynomial. We can graph it from this. This is actually a much more efficient form because you can see the zeros right there. You know it bounces at this one. And you know it's stretched by a factor of 2. And you can plug in anything here to any equation. You good? So 39, that's all I was looking for, and I think this is more useful than a polynomial, so I said stop there. 40. 40 says it's also a fifth degree, and it has real coefficients, so 0 is the only real 0. Okay, x equals 0 is one of them. 1 plus I is another one. And this has only 1 as its multiplicity. So what does that mean? Well, that means that if this is an imaginary one, its evil twin has to also be part of this. So they tell me this one, I have to include the other one. So I'm going to say and 1 minus I. And if this one has a multiplicity of 1, which means there's only one of them, then this one has a multiplicity of 1 because they come in pairs. So if this is 1 and 1, how many zeros are there that are 0? If it's fifth degree. So I've got y equals x to some power, and then I've got x minus, so that's a circle, not a 0. X minus this one, 1 plus I, to the 1. X minus 1, this one, minus I, to the 1. So I need 1, 2. How many does this need to be to make 5? What is it? It's not 5. It's going to be 3. Because 3, 4, 5, now we have them all. You see how we're just puzzling it out? Okay. Good. 41. What do we know for that one? It says it's a fourth degree. The x-intercepts are 0 and 6. So what does that mean? It means we have a point 0, 0, and we have a point 6, 0. That's what x-intercepts are. They're the same thing as zeros. So x equals. Negative 2 is a 0. I'm sorry, negative 2i is a 0. So that's going to be, how do I put that in my list of stuff? I'm going to rewrite this. X equals 0, 6, 2i, negative 2i, and then they said the leading coefficient is 3. So this was messy. I rewrote it. So they gave me these 3. They told me the leading coefficient is 3. That means I multiply the whole thing by 3. So my polynomial is going to look like, if I multiply it out, 3 times this one, x. Or x minus 0. Put that in there if you want. It's fine. X minus 6. This one, x plus 2i. What else? X minus 2i. If we have this one, we have to add our own. We're going to add 2i because these are pairs. And now, fourth degree, 1, 2, 3, 4, done.
How come you only put like the negative 6 by itself instead of like I put down like x minus in parentheses 6 minus.
Okay, because they had commas in between them. It says the x-intercepts are 0 and 6, comma. Negative 2i is a 0, was its own sentence. So 0 and 6 are regular numbers, and then this is our imaginary one. So what that means is that this fourth degree one, if we graphed it, it would have a value at 0 for this one. It would have a value at 6, 1, 2, 3, 4, 5, 6. And then I don't know exactly what it does. I mean, I could graph it in a calculator. I could multiply it out and have a better idea of what it does after that. But it means that if it's 6 degree, it's going to have some other wiggle in here that doesn't cross the x-axis. So it has, because it's a fourth degree, it could turn 1, 2, 3 times. And the extra wiggles are because I can't see intercepts. They happen off of the x-axis. They're imaginary. So really, it was just a matter of punctuation. Because if you saw it as together, I could see that. Okay, so that was us going through the rest of the problems from 4.4. We started to talk about rational ones, and I'm going to put that in a separate video so it all makes sense going together.